afternoon, everyone, and welcome to today's webinar on smart water trends in the U.S. My name is Adlane Fellah. I'm a senior analyst with Maravedis, the boutique water analyst firm since 2002. Today, it's really my pleasure to present a few slides from a recent research survey among utilities and moderate a great panel of speakers from the water and connectivity industry. Today's webinar is sponsored by the LoRa Alliance. Before we start presenting, I would like to present some housekeeping notes. Please submit your questions to the Q&A engagement tool below the slides. A copy of today's slide deck and additional materials are available in the resource list. The webcast is being streamed through your computer, so there is no dial-in number. If you cannot hear the audio playing, check your speakers or headset. Some networks cause slides to advance more slowly than others. If your slides are behind, pushing F5 on the keyboard will refresh the page. Today, I have the pleasure to be moderating and presenting a great panel of speakers, including Barbara Martin from the AWWA, Donna Moore, CEO and Chairwoman of the LoRa Alliance, and Bruce Shapley, CEO at Senate. Water is a scarce resource. Pure water is not available only. It only represents 2.8% of the total available water on Earth. And from that, drinkable water is only 1%. This is why the United Nations has set a global objective for all nations to provide safe and affordable drinkable water for all by 2030. This requires we invest in adequate infrastructure, provide sanitation facilities, and encourage hygiene. Protecting and restoring water-related ecosystem is essential, and is one of the reasons why we are having this webinar today. Water stress is defined by the World Health Organization as follows: when availability of water per year and habitant is less than 1,700 cubic meters. The WHO analysis finds that 37 countries currently face extremely high levels of water stress, meaning that more than 80% of the water available to agricultural, domestic, and industrial users is withdrawn annually. Water stress affects more than 2 billion people, with this figure projected to increase and reach 3 billion people by 2035. Now, moving on to my presentation, I'll be presenting today some survey results from a survey we conducted in the fall of 2020. I will be presenting some of the top use cases that were more cited among the respondents. And my focus today will be on advanced meter infrastructure. Why bother investing in a reliable AMI system? What for? Use cases range from reducing non-revenue water to improving customer service. The survey we conducted had a special focus on smart meters and AMI, enabled by low-power, wide area networks. When it comes to metering and AMI, each vertical has its own requirements. We look at the water utilities and water companies' opinion in terms of their wish list of how the technology should behave and support. Finally, we'll address some of the challenges that may slow down the adoption of water metering and AMI in the context of the U.S. market, which will be a segue to pass the torch to Barbara Martin from the AWWA, who will present the state of the U.S. industry, providing a more global perspective and more comprehensive view of what U.S. utilities' concerns and realities are today. For those that are not familiar with Maravedis, we're a boutique analyst firm since 2002. We provide essentially lead generation and thought leadership services to our customers. A few words about the survey. The survey took place last fall and was conducted in various regions of the world across a number of sectors, including water, heating, gas, and electricity, accumulating 111 responses from utilities. A quarter of these responses were directly related to the water industry, and we have drawn some conclusions and findings for the water industry in this presentation. The majority of water utilities have deployed proprietary AMR system. AMR meaning automatic meter reading, which is a solution that consists of a wireless data acquisition device which captures real-time energy meter data and shares the data to a remote place through a wireless handheld device. We also know that the majority of networks are citywide networks, indicating the majority of utilities for the water industry are city-owned or private companies operating in a single city, which size can vary from hundreds of meters to hundreds of thousands. A few words about Lpwan. The Internet of Things starts with connectivity, but since IoT is a widely diverse and multifaceted realm, we certainly cannot find a one-size-fits-all communication solution. Each solution has its strengths and weaknesses in various network criteria. By providing long-range communication on small, inexpensive batteries, Lpwan technologies are purpose-built to support large-scale IoT network sprawling over vast areas from cities to agriculture. Now diving into some of the top use cases for AMI, each sector, such as water, heating, or gas, have their own particular set of requirements or use cases. And in this case, the water utilities are looking to use advanced metering infrastructure, which is the acronym for AMI, primarily to read meters on a timely and cost-effective basis. This capability in turn enables the reduction in operating expenditures from wasting water and detecting leaks on a more timely basis, and also in turn avoiding bill shocks to end users and giving customers the ability to monitor and control their water consumption. AMI also enable utilities to be more efficient and improve their operation processes. For example, removing the need to send field technicians to inspect a particular part of the network and managing parts remotely. When it comes to advanced metering requirements, we can infer from the survey responses that battery life and network availability come first in the mind of utilities. That's followed in the survey by data security, which is increasingly sensitive as cyber attacks become more frequent and we more see risks and consequences. And I believe Barbara at the AWWA will discuss some similar findings in her State of the Industry survey. Network availability in this context is related to the amount of time the network is up and running. There will be constant monitoring of the meters and other part of the water infrastructure. Some respondents have also indicated that they interpreted the question as related to network coverage, which may be an issue in large part of the U.S., as Lpwan networks, contrary to traditional cellular networks, are built based on demand in a particular area. Challenges, there's no shortages of challenges, real or perceived, faced by utilities. And not all challenges are technical, as financial and business issues are very critical and represent a real impediment to a faster, more aggressive adoption of AMI. As you can see here, many utilities, especially water utilities, may be cash-strapped because water is a regulated market and utilities may not be able to pass on the rising cost of new investments to their end users, as well as other utilities can do. Let me explain why utilities are so sensitive to the line item of the price of end nodes, that is the smart meter device in their budgets, along with battling for budgets for their boards, whether they're city-owned or private. The lack of clarity of the business model is also an issue, one that may be alleviated as utilities can expand into new use cases related to smart city applications that can enable them to generate additional revenue streams to pay for their water capex. Others, utilities see the lack of interoperability as a raising issue, when they have to manage a legacy and a proprietary AMR system while introducing a standard-based AMI, and having to support two separate systems that don't talk to each other is definitely an issue. I have a reverse slide here. So this summarizes some of the findings from the survey, looking at the top use cases, requirements, and benefits. Bottom line here is water utilities want to reduce non-revenue water from all sources, leakage, pipeline bursts, etc. They want to improve the overall customer service with precise billing and alerts and outages, and improve the overall operational performance, as we discussed earlier. To do that, they have requirements in terms of what the equipment can do. And so they require long-range connectivity with deep indoor, and some of the meters are in basements and under large parts of concrete, and need very high sensitivity modulation to be reached. Battery life, increasingly in the U.S., is now 20 years, up from 10, 15 years a few years back. And the reason is that utilities want to be able to replace the meters at the same time at the end of the life cycle of the battery, so you don't have to go there twice. So another very important requirement there. Also, utilities want to be able to support both AMR, walk-by reading, alongside AMI, and in a smooth and efficient way. As they transition from proprietary AMR, they're looking at standard-based system with a strong ecosystem that they can choose from in terms of device availability, pricing, etc. Increasingly, water utilities have told us that they want to use a single platform for supporting other smart city use cases, such as smart lighting, parking, what have you, which are possible ways for them to generate additional revenue streams. In terms of the actual benefits of the technology, I mentioned phasing out aging infrastructure in an elegant way. Most of the utilities in the U.S. don't necessarily have a very strong telco IT staff, that they rely on a public or hybrid networking and use connectivity as a service. And our friend at Senate will discuss this particular aspect of connectivity in the U.S. So this slide summarizes the situation of the U.S. water market. Very interesting market, a very large opportunity for AMR and AMI with 200 million households in the U.S. Very fragmented market with 40,000 plus utilities, but Pareto law applies here with the top 100 water utilities driving half of the market. As I indicated earlier, it's a market dominated by AMR. And North America constitutes today the leading market for both AMR and AMI solutions. As I mentioned earlier, IT skills are lacking for most utilities, so they will rely on companies like Senate to outsource their connectivity service. And IoT is really now driving a new deployment model based on demand. So contrary to traditional cellular, where they build and they will come, in the context of IoT and AMI, this is really driven by the demand. So it's really for utilities to raise that need for connectivity to make that happen. The good news is it's much easier to densify a LoRaWAN network than it is a cellular network. In summary, the U.S. market is very fragmented, but the metering has great potential, as we discussed. The utilities are increasingly motivated, incentivized to become more efficient, to reduce waste, to provide customers with power and empowerment to control their usage and bills and become more eco-friendly. So that's definitely a driver for investing in new technologies. Utilities are conservative when adopting a new technology, but once they do, they're in it for a very long haul. We're looking at 20 years replacement cycle here. We have seen the requirements that include long battery life and the move transition to from AMR to AMI, and a platform that's scalable to add the new smart city services that we all envision and looking forward to happen on a more scalable basis. And as I mentioned, IoT is driving a new deployment model based on demand, so which is quite different from traditional cellular networks. And so with this, I would like to introduce Barbara Martin, who's Director of Engineering and Technical Services at the American Water Works Association, who's going to give us a more comprehensive perspective of what the pain points and the demographics and provide some additional details of what the American utilities market look like based on their yearly State of the Water Industry report. Thank you. Barbara, it's all yours.
Excellent. Thank you, Adlane, for that introduction. As Adlane mentioned, I'm going to speak about a broader AWWA survey that has some nice connections to smart water and also helps to support many of the use cases that Adlane mentioned earlier. This report is called the State of the Water Industry. But before we get into the report itself, I want to speak just briefly about the American Water Works Association. So AWWA, as we're known, is the oldest and largest association of water professionals in the world. We have more than 50,000 members and work with thousands of volunteers from across the globe to develop resources to support the water sector. AWWA is headquartered in Denver, Colorado. We have an office that supports advocacy in Washington, D.C., and then also do work in Mumbai, India, to truly realize our vision of building a better world through better water. So some of the resources that AWWA focuses on developing are listed on this slide. So we do work to develop ANSI accredited standards to support the water sector, including standards on water metering. We have a variety of manuals of water supply which touch on all aspects of utility operation, including water auditing and water loss control. We support the development of many virtual and in-person conferences and educational resources. We have a variety of peer-reviewed publications, offer many volunteer opportunities to individuals to support the sector, and then also focus in on industry research, which the State of the Water Industry survey certainly represents. So this year's survey marks the 17th continuous year that AWWA has been soliciting this data from water utilities. The survey had over 3,000 responses. A little more than half of them came from the utilities, and of the utilities surveyed, 88% of them were public utilities. Survey respondents represented a broad swath of utilities. There was good representation from our smallest utilities, serving populations of less than 10,000. And then about 71.4% of utility respondents served a population larger than this. Most of the survey responses from utilities came from executive or management type functions, including financial management. And the next most common respondent for this survey was from utility operations. So certainly the right people were answering the questions that we asked them this year. So to start off, one of the questions that we ask on a perennial basis in the State of the Water Industry survey is people's opinion of the current state of the water industry and how sound they believe the industry will be 5 years from now. So given that the survey was conducted in 2020 and the survey ran from about September to November of 2020, we just didn't know what to expect this year. It's a pandemic, it was a challenging year, and we just kind of didn't have a clue how those numbers were going to turn out. So imagine our surprise when the survey resulted in the highest results ever in its history in terms of the state of the water industry and optimism towards the future. When I think about the drivers for these somewhat unexpected results, really I think of three things. One of them is innovation. As Adlane mentioned, the water industry is conservative and sometimes a little bit slow to innovation. The COVID-19 pandemic certainly forced our hand at innovating much more rapidly as we had in the past. The second reason is how quickly the utility industry came together for the rapid deployment of resources and activities to support the sector. Lots of resources developed in a very, very rapid manner, including the rapid distribution and deployment of PPE to water systems of all sizes. And finally, the third driver for this that I see is collaboration. Really, utilities came together during this time of crisis and supported each other to a level I'm not sure I've seen in my 20 or so years with the sector. So very encouraging results in terms of people's attitudes about the water sector this year. Another component of this survey is outlining the top 20 water sector challenges. And the top 10 are on this list. As you can see, the top 2 are renewal and replacement of aging water and wastewater infrastructure, as well as financing for these capital improvement projects. I've highlighted emergency preparedness on this list. This was something that jumped up several spots on the list this year due to the pandemic. And I'll give you a moment just to read the rest of the results on this slide themselves. One thing you might notice is how really all of these tie to smart water in some way and can be benefited by smart water in some way or another. Certainly our top 2 results are aligned with what ASCE recently came out with for their 2021 infrastructure report card. We got a little better last year, but drinking water is still rated at a C-, wastewater not far behind at a D+. So certainly a recognition all around that there's room for improvement in the industry. Rounding out the top 20 challenges are issues like cybersecurity. And this survey was conducted before Oldsmar, so this one's another one that's highlighted because it jumped up in importance over the years. So there's an increasing recognition of the need for cybersecurity, which certainly goes hand in hand with smart water. And some of the other strong ties to smart water include asset management, water conservation and efficiency, data management, and water loss control. So certainly among those top issues, represent some good drivers for the use of smart water technologies. This slide indicates how these various issues, the top few, have trended over the past few years. And you can see from 2017 to 2021, renewal and replacement of infrastructure and the financing to support that remain perennial issues. In fact, most of the top ones do, with the exception of emergency preparedness, as I mentioned earlier, jumped up several spots this year because of the pandemic, but really it just pushed all of the other existing issues, such as public understanding of the value of water, a little bit lower on the list. So what do industries do to address these challenges? One of the things they do is plan. And we did ask in the survey about various operation and maintenance plans and programs that utilities have implemented and plan to implement. And the good news with respect to water loss control programs is over 77% of utilities have these programs either fully implemented or have implementation in progress. And this is important because water loss is a significant issue. A 2013 AWWA report quantified the water loss for a group of 246 utilities, and what they found was 130 billion gallons in total annual leakage, which cost these utilities $77 million in additional treatment and pumping costs. And that's not even getting to the apparent losses and the lost revenue in terms of consumption. So good to see that plans are headed in the right direction with respect to water loss control. So one other thing I want to point out is utilities' ability to cover the full cost of services. This is a question we asked this year to quantify the economic impact of COVID-19 a little bit better. And this slide represents how utilities felt about their ability to cover the full cost of services. The dark bar is prior to COVID-19, the light bar is after COVID-19. And you can see on this slide a shift. Before COVID-19, utilities were much more confident in covering their full cost of services, and that shifted to being less confident in covering the costs during the COVID-19 pandemic. In a report conducted by Tellis with collaboration from AWWA and AWWA in April in 2020, quantified the estimated impact of COVID-19 on our water and wastewater utilities, and we were looking at an impact of over $30 billion in total. So, water utilities looking to fund these necessary improvements, the most popular option is water rates. And for water rates to really be successful being implemented, it takes public buy-in, which takes communication. And this is another place where smart water technology really ties into this issue. The technology collects the data, which helps utilities tell the story and really define for their customers the value of the water services that they are receiving. So just a couple quick things to tie up my presentation with respect to resources that relate to water loss control, as well as smart water. And you can see some of these on this slide. On the left, we have a report of non-revenue water performance indicators, which may be downloaded from AWWA.org. We also have a manual specifically on water audits and loss control programs, along with accompanying free water audit software, which also can be downloaded from the website, and a variety of ANSI accredited standards. And the one displayed on this slide has to do with cold water meters. AWWA also offers a number of events that are more specific to water loss, including the North American Water Loss Conference, which will take place hopefully in person later in 2021, and also the Water Infrastructure Conference. And water loss is such an important issue to utilities. It is something that is regularly incorporated into AWWA's annual conference, which is taking place virtually this June. So hopefully that's given you an opportunity to see a bigger picture of water sector challenges and how smart water ties into it. I'm going to go ahead now and turn it over to Donna from the LoRa Alliance to address her area of the presentation.
Great, thank you, Barbara. I just wanted to say Adlane and Barbara did a great job identifying the water crisis. And what I have to say is 2 points in the presentation today, and hopefully it's around the solution. And the first point I'm going to cover is what is LoRaWAN. I'm sure many of you have heard of LoRaWAN, but I'm going to go over why LoRaWAN and LoRa Alliance exist. And I'm also going to talk about why the LoRaWAN standard is the solution for the water crisis. So I'm going to move forward. So the LoRa Alliance is an open global standard. We've been around for about 6 years. And the LoRa Alliance focuses on is develops, promotes, and maintains the LoRaWAN standard. And why is an open standard important? It's critical to have a standard, particularly in the water industry, because the standard allows consistency, it allows innovation because it's open, particularly with a large membership, and it allows for interoperability, key items that are needed within the water industry. The other thing that's very important that the LoRa Alliance does is we manage a LoRaWAN certification program. And the certification program is key because when these meters are deployed, we know it's a very long 15, 20-year life cycle. Many are buried underground. It is critical that these devices have been certified so that you know they're going to work as intended. The LoRaWAN certification program tests conformance, RF, interoperability, as well as security. So when you're looking to purchase and move forward for your AMI, it is really important to look at LoRaWAN certified devices because you need to be assured of the confidence. So just as an example, here is many of our members that have smart metering solutions. So there's smart water meters, there's smart readers, there's leak valve detectors. We also have reference design and platform. So it's important to note that this is just a sample of the types of members that we have that offer varied solutions, that offer choice, that brings costs down for the water industry, because it's important to have choice. So let me move on. When I talk about choice, I talk about our very large ecosystem. And if you look, we have one of the largest IoT ecosystems around the globe. And that's important because, again, we want competition. We don't want the water industry to be locked into one proprietary solution. That's probably one of the biggest mistakes that's been made in the past. And that is when you pick a proprietary solution, you are locked in. You're locked into the control of that long-term contract. There's no choice. There's limited innovation. There's limited ability to expand your market and grow. So it's very critical that you look at an open standard that has a plethora of members that can provide all the needs today and also in the future. So let's look at why LoRaWAN specifically for water metering. And I love this slide because it really identifies why LoRaWAN works so well for AMI. So let's start off at the left side. So basically we know that the water industry needs a flexible network, and LoRaWAN provides public networks, private networks, and even hybrid networks, depending on the need of the customer. We also know, as you heard in Barbara's presentation, that money is an issue, budget is an issue. And so LoRaWAN members provide either a CapEx, where you can buy the equipment and manage it and expense out over the years, or an OpEx, or a service model, where if you don't have the capital, you can contract for a service model that allows monthly billing on your financials. So it's a great choice of flexibility, particularly with the financial needs that are happening today. So next, there's firmware update over the air. And why is that important? We need to make sure that those 15, 20-year meters that are buried can be updated, can be shut down if there's emergency services, that can talk back and forth. So firmware update over the air is a key need for the water industry. Bi-directional security, we know that security is important, and LoRaWAN was built with security in mind. Our very large ecosystem has all of the key players, from devices to security to network players to a whole ecosystem of players that are the experts in each area and contribute to making LoRaWAN the very best standard for water. And that is why we were built with security in mind bidirectionally. I know that the long battery life is critical. LoRaWAN's battery is 20 years, and you need to depend on that, because if you have a battery life that has not been tested and has been buried and something happens, that is an issue, obviously, for cost, going up and reburying, redeploying. So you need to know, and again, that's why certification is critical. So next we have long range and deep penetration, and that is really important for the meters that have been buried underground, under concrete. LoRaWAN does a phenomenal job through concrete, through steel, through long distance, reaching the network. So that is very important in water, in particular with the meters. We have a strong ecosystem, as I identified. And again, I'm going to say one more time because it's so important as a standard. The larger the ecosystem, the stronger the ecosystem, the open ecosystem will allow choice, bringing down costs, will allow you to grow as you expand your business. And finally, the easy to scale. So it's very important, again, that as a standard, you can add in more and more use cases on your network that's already been deployed. And why is that important? That's important because we know that IoT is scaling. And once you have a network infrastructure in place, you can add more and more and more use cases, and your costs and ROI, your ROI increases and your costs go down as you continue to use the same network. So let me show you really quick here. Here are just some examples of what a standardized large ecosystem can provide and additional use cases. So with water metering, you're looking at leak detection, water quality management, distribution management, waste management. But as a smart city, you've got the infrastructure in. You can just add new devices to that already infrastructure that's in place for lighting and parking and trash bins and traffic lights. And LoRaWAN is so easily, unlike cellular models, to expand. You can densify by just adding up a new gateway. So densify to add more and more and more use cases without putting in a whole new infrastructure. And in agricultural areas, we have irrigation, crop management, landscape planning. It goes on and on. And these are just some of the examples that once your network is up and running, whether it's a CapEx or OpEx, you can continue to use that infrastructure. So with that, I'm going to move forward to Bruce. Let me get him up there. And Bruce is the CEO of Senate. Bruce, would you like to take over?
Yeah, thank you, Donna. Well, thank you to the other speakers. I'm Bruce Chatterley. I'm CEO of Senate. We happen to be headquartered in, but I happen to be here in Seattle. And speaking of water, boy, do we have water coming down today, which is not atypical. Let me just get started. Where the previous speakers talked a lot about customer research and standards, I'm going to try and focus a little bit more about how we implement these networks with real customers and how they've been, kind of the experience that we've had in actually building these networks. Before I do that, I'd like to give you a quick overview of Senate. We are a developer of cloud-based software and services for the on-demand deployment of IoT networks where they're needed, when they're needed, and at the right cost. So we really focus on helping utilities, water, gas, and electric utilities build really purpose-built IoT networks for their specific applications, geographies, et cetera. So we focus on utilities. We also partner with enterprise application developers for both indoor and outdoor applications, as well as operators like cable companies, wireless companies, and they use our platform to build their own IoT networks based on the LoRaWAN standard that they can use to sell to a variety of different customer segments. So over the last 2.5 years, we've had a lot of experience, both positive and learning, working with water utilities. We've designed over 100 AMI networks across North America and the world over the last 2.5 years. Many of those networks we designed are up and running, and many of them are being built as we speak. So I'd like to focus a little bit now on how these things get built and how they get used. And at the end, I'll talk about a specific case study in terms of one of our partners and how they've actually quantified the benefits they've received from the implementation of an AMI network based on the LoRaWAN standard. Before I get too far into kind of the nitty-gritty of networks, I wanted to just set the context at a very high level for how we view the LoRaWAN standard in the context of the other alternatives available for creating these AMI networks. So in terms of IoT connectivity, we divided it into 3 technology categories. The first is applications that are powered and wired. So that would be like Zigbee, Bluetooth, Wi-Fi. The second would be applications that require very high bandwidth two-way communication. And so that's really characterized by cellular technology, and that's things like real-time video or telematics for driverless cars, those kinds of things. The third category is called low-powered wide-area networks, which the previous speakers have been talking about. And most research has identified that as being more than half of the overall IoT device connectivity market. And so this market's characterized by applications requiring very small bandwidth in terms of data, very long-range communications, and that really translates into efficient network designs, and very low cost. These, as identified by long battery life and devices that are available at very low cost, because this category really represents millions and millions of potential deployments in terms of devices, in contrast to the other 2 categories. So this slide is really to talk about the experience that we've had and the feedback and the themes that we're hearing as we build these network designs and implement these networks. And so as I think about our experience over the last couple of years working with utilities, in particular water utilities, we kind of have 6 key themes that have emerged, which actually echo a lot of the research that the previous speakers have talked about. The first is that utilities are looking for targeted and unique network designs that reflect both their unique geography, the unique service locations that they have to cover, and in many cases, the unique municipal assets that are available for deployment of gateways and and collectors. But almost as importantly, and this is a unique attribute of LoRaWAN, is they're looking for specific service level agreements that define the performance of the network in terms of quality, reliability, and uptime. And so that's a unique thing for LoRaWAN networks that can be purpose-built, purpose-designed for those attributes. The second major theme is they're looking for, once the networks are built, into strong visibility into both the performance of the network, but also the performance of the devices. And the two are sometimes separated, and the two are sometimes tied together. And they're looking for visualization and control tools that allow them to decide when they're having problems, how do they address those problems, and how can they diagnose and control those problems. The third theme is that they're looking for a constant stream of innovation. So the one thing we're certain of is that we haven't gotten it right when we implemented our cloud-based system from the beginning. And so we're constantly listening to customers in terms of their experience and features and functionality that they need. And we chose a cloud-based deployment for our network management, monitoring, and visualization tools. And what that does relative to innovation is it allows us to listen very carefully to customer needs, build those features, and rapidly deploy those. Because it's a cloud-based solution, we've done over 50 releases over the last couple years without a moment of downtime. And so customers get a direct relationship between their feedback, us building the features, and delivering it very quickly. So that's the third theme. The fourth theme is around security. And I think it goes without saying that for critical infrastructure, which water fits well within, security is really key. LoRaWAN as a standard has the best security model of any connectivity model available for IoT today, where encryption starts at the device and carries all the way through the network, and the encryption keys are not available until you reach the application, which is controlled by the actual application provider / customer. So security is key to these customers, and LoRaWAN is best in class. The fifth is bidirectional communication. And so it's not enough to have good, solid communication upstream for meter data and leak detection, but also you need the ability to efficiently address the device for things like valve shutoff and shutoff for non-payment and those kinds of things. And the LoRaWAN standard is extremely efficient, where other IoT connectivity can do downstream bidirectional functionality. The cost of doing that, both in battery life and in actual network costs, is very high relative to LoRaWAN. The last thing is that I talk about in terms of themes we're hearing from customers is cost effectiveness. So we're often talking about network designs that result in a minimum of tens of thousands of devices deployed, but very often hundreds of thousands, if not millions of devices. And so the open ecosystem, the open standard, as Donna said, for the LoRaWAN standard results in highly efficient production and choice on the manufacturing side for meters and the communications components. But more importantly, the battery life is a key component of cost, overall total cost of ownership. And the shortest life networks that we're contracting for is 10 years, but more typically it's 15 to 20-year life that we're guaranteeing both for the battery and for the network. So those are the themes that we're hearing from customers as we work on solving their problems in terms of purpose-built AMI networks using the LoRaWAN standards. What I thought is I'd talk through just a couple examples for how we actually design and implement these networks. So the design, as I said earlier, is critically important because it reflects the unique geography of the utility that we're working with, as well as their unique SLA and coverage requirements. And so we start often with a file from the utility that has the list of service locations that are geocoded that they want to cover. The second file we usually start with is if available, is a list of municipal assets available for deployment of gateways. We import those two files into our cloud-based network planning and design system. And the output of that is a network design that shows very specifically service level agreement backed deployment metrics in terms of the performance of the network, the number of devices that will be covered, and budgetary pricing in terms of how that network will be implemented. Then we acquire the sites required for the implementation of the collectors/gateways. We construct the network, and then we do a full verification and SLA match in terms of service level agreements, the metrics we're guaranteeing. We confirm that against the network design and the actual implementation of the network, and we deliver that network to the utility. So once the network's delivered, our system has a very rich set of scalable deployment and monitoring capabilities. And so we designed all of our cloud-based systems for scale. So, what's important is you have to be able to register tens of thousands, if not hundreds of thousands of meters to the network simultaneously. Then you need to deploy those, and you need to very efficiently assess performance issues as you deploy and as these meters get in market. So we have a rich set of visualization tools which show how the devices are performing, how the network's performing, and a series of alarms and monitoring tools that allow you to quickly diagnose problems and address those problems. So the other thing that's important, and I think Donna touched on this, is that not all utilities' needs, interests, and technical operational capabilities are the same. And so we're finding that there is a growing, in fact, the fastest growing segment of our business is public/network as a service. So this is the model where the utility asks Senate, along with a metering partner, to completely outsource the network. So design it, build it, own it, operate it with service level guarantees, and the metering company will deploy the meters and focus on being a water utility and delivering great and efficient customer service. So that's very fast growing. There are a lot of utilities that like the historical way of doing business and have those skill sets, and that's called a private network. So a private network in our mind is defined as a utility that wants to buy the gateways, deploy the gateways, operate them. And private also from a security standpoint means that the meters can only connect to those gateways and nothing else can connect to those gateways, either from inside or outside the network. In that model, we're finding a very, very fast growing segment that we call hybrid. And so this is a private network as I've just defined it, but the utility allows other applications to connect to those private gateways for rapid adoption of smart city applications. Senate has invented a concept called the Lpwan virtual network, or LVN. And what this allows is if the utility allows Senate's application partners to connect to those gateways, not only can the utility quickly adopt and deploy new applications, but we will share a percentage of our revenue from those application customers with the utility for allowing those connections. And so it's a really a win-win solution for both the utility, the applications company, and for Senate. So what we're also finding is that water utilities become the anchor application for, to really catalyze the deployment of a very, very dense network. Because water meters often exist in pits and in hard-to-reach places, the networks we design for water utilities end up being very dense outdoor coverage applications, as well as providing very strong indoor coverage. And so as a result, what we're finding is utilities and the municipalities they are embedded within or represent can then deploy a wide variety of other applications using that anchor network. And this can include things like smart city applications, and other utilities could also ride on that, including electric and gas utilities. So with that as context, I wanted to close with a real-life example / case study for one of the customers that we've deployed an AMI network for. So this utility has, I guess you would consider them small to medium size. They have about 30,000 total meters. Their smart meters were deployed in pits using a standalone MIU. And as a result of their requirements, we designed a network as a service where it's a totally outsourced public network, but purpose-built for this utility. We designed and built that using a combination of commercial towers as well as municipal assets because some of the meters were in extremely hard-to-reach areas. That network took about 90 days from start to finish to fully implement. And we deployed about 14,000 meters within 6 months. And that initial deployment was so successful that we're just starting on the next 7,000 meters to have a total of 21,000 meters in the first little over a year of deployment. So as we talked to the utility to determine exactly what the results of this AMI deployment based on a LoRaWAN standard network was, we got a couple really specific examples of benefits. The first is cost reduction, and that is manifested both in their ability to completely eliminate a third-party meter reading contract, but also in the form of waste water loss or wasted leaked water loss. They moved from 12% water loss to 3.5%, and I think it's continuing to improve. The other thing that they experienced is tremendous improvements in customer service. So now that you have the data at your fingertips about what's happening at a very granular level at the customer location, you can proactively notify the customer of leaks. But as importantly, customer service representatives will have that information at their fingertips, and they can provide better customer service and resolve either disputes or questions more quickly, which also results in better employee morale, reduced carbon footprint, so a better environmental impact by reducing trucks required for drive-by metering, and then employee safety during the COVID pandemic, because now you don't need to send employees into the community to read meters. And lastly, we're in the process of evaluating and deploying additional applications. So the picture you see on the right is an example of the real-life network design, an example of a gateway deployed, and a picture of the meters that you get from the Senate platform and the Senate system in terms of what the deployment looks like across this municipality. So with that, I'll close by giving you some resources. So if you have more questions about Senate, or if you'd like to just poke around and do more research on LoRaWAN and the building of these networks, please visit the Senate website, which you see on your screen here. And with that, I will turn it back over to Adlane to close and take questions. Adlane?
Thank you, Bruce, and thanks to all the presenters for great material, good content. We will now open the webinar for some live questions from the audience. Okay, great. So let's start with the first question. And thanks again for the great presentations. So we have perhaps first question for Barbara at the AWWA. You have provided some good insights about the state of the industry. How have water utilities been impacted by COVID-19 in addition to the financial impacts which were discussed during your presentation?
That's a great question. Thank you. So AWWA conducted a series of pulse surveys starting in about April of last year and running through the summer to really try to get a good handle on some of the challenges that water utilities were facing specific to the pandemic. Some of those identified during that survey were workforce challenges, both related to keeping workers safe and at a distance, as well as challenges with absenteeism. There were some challenges experienced relative to the supply chain, both of things like treatment chemicals and of PPE. challenges in facing operator education with the quick switch to virtual and a lack of in-person workshops and training, which is still continuing, just starting to come back slowly. And probably one that relates most to this topic is low water usage and stagnation of water impacting water quality in buildings. And many utilities were able to use water meter data to get a feel for what industries, what companies experienced low water usage so that they could do some proactive outreach to these organizations to encourage them to follow CDC recommended guidance in terms of water flushing to maintain water quality, particularly as those buildings are repopulated. So you can see all the details of these surveys at awwa.org/coronavirus and get a feel for more of the details. Thank you.
Thank you, Barbara. Great. And by the way, we're getting a lot of questions from the audience, so thanks again. We won't be able to answer every question during this live webinar, but rest assured that we'll follow up with you and answer some of them in writing, and some of them have been or are currently being answered through the live chat box as we speak. Second question here for Donna at the Law Alliance. The question is, you mentioned that LoRaWAN is standardized / certified. Can you speak to the lack of interoperability on the application layer, which is needed for water devices? If the goal is true interoperability, what are your thoughts on this challenge?
Yes, hi. Well, the goal is true interoperability, and the LoRa Alliance is working with many standards associations, especially in the metering industry, to ensure that the interoperability on the application layer. And just to clarify, the LoRaWAN certification is for the device. It's device certification to ensure that it can connect with our LoRaWAN networks and security and all the other things that are tested. So an example, particularly in the water industry, is wireless M-Bus, right? So LoRaWAN has many bridges that are LoRaWAN certified and used to connect wireless M-Bus over LoRaWAN. And, LoRaWAN is really widely being used in metering in general in industry by energy utilities as well. So just another example of working with another standard is DLMS over LoRaWAN, which is used primarily for smart electric metering. But that is our goal, is we work with other alliances to bridge the gap from what was to where we're going forward and to make them a truly, an open Lpwan standard.
Okay, great. Thank you, Donna. Now your turn, Bruce, at the Senate. We have a question here, which is very interesting because we touched on that regarding AMR and AMI coexistence. Do you have scenario solutions on which installed base AMR system, usually based in M-Bus, are backed by LoRaWAN gateways to deploy AMI?
Yeah, so setting the M-Bus comment aside, because I'm not an expert in M-Bus, but relating to AMR, I think it's a very important point because many utilities take time to transition to a fully AMI network. Some never fully transition. Some transition over a long number of years, and so I think we're finding that it's actually very common to have a coexistence of LoRaWAN-based AMI and AMR in the same network for either some period of time or permanently. And so I think the rationale is either transitioning, or there are some really, really difficult to reach places for any communications technology, by geography and by location, that almost always require a non kind of over the air generalized RF network. So I think what I would say is it's important as you consider deploying an AMI network, and if those conditions exist, to really seek a partner that has both on the hardware side the flexibility to do this, as well as on the application side the flexibility to take multiple data feeds and create a single consistent interface.
Great, thanks, Bruce. Our time is almost up, and we do respect your busy agenda. So unfortunately, we'll not be able to answer all of the questions right now at the moment. But rest assured that we'll follow up in writing and answer the many questions that have been received. A lot of them very technical, and most of them very interesting. And I want to thank the presenters for their great presentations today and for answering the questions. I want to thank the LoRa Alliance for sponsoring this webinar, and of course the audience for tuning up. And that ends the webinar today. Thank you very much.